Welcome to the third section, Defining Interfaces with Traits. We're going to show you how to define public interfaces with traits, and combining this with generics, we can solve most of the code reuse problems we might face. So if you are familiar with Java interfaces, traits are very similar to it, but has more power. You can define a shared functionality for multiple types using traits. The way you do it is to define a set of methods to fulfill a certain purpose. And each type can implement these traits by implementing all the functions it requires. So let's take a look at an example. Let's say we have a trait called vehicle. Vehicle trait had three different methods: new, move, and toString. So anything that wants to be a vehicle has to implement the three functions. They're all slightly different. First, look at a new function. It does not take self as a parameter. That makes it a static method. Rust doesn't have a specific constructor method, so it's a convention to create this new function as a constructor to create your trait object. The second one, move, takes self as a parameter, so it's an instance method, and it's here only as a signature. That means this trait has to have this function, but you don't have to provide an implementation. The third function, toString, does have a default implementation, so you can provide a default implementation for your trait methods. And now we have three types: airplane, bicycle, and car. These three types, we want them to all work as a vehicle, so we use the IMPL, the implementation syntax, to implement the traits on all three of them. As you can see, we have to provide an implementation for new and move, but not the toString because we have a default implementation. Each one can implement its move function, which makes sense for itself. It's not enough if we only encourage people to use this vehicle trait, because we want to actually enforce people to implement it. So let's take this generic function as an example. If it takes a type T, and we want to use the move on this type T, we have to ensure that every type T that passes into it has to implement the vehicle trait, so it has the move function. That's why we can use this thing called trait bounds. That means this T must implement vehicle trait. So if you pass any parameter, if you pass any type T into here, which doesn't have vehicle traits, the compiler will complain and your code won't compile. We'll dig deep into trait bounds in the next section.